So yes, all right, great. Thank you, everybody. My name is Harry Koehnemann. I'm with a company called Scaled Agile. We author the Scaled Agile framework. I'm on the framework team and help evolve it. And I spend most of my time working with organizations for the last probably 20 years or so in aerospace, defense, automotive, big cyber physical type systems. So happy to be here and happy to talk with you about how we're applying Lean Agile practices to specifically in the automotive industry. I want to start with I'm going to try to start here. There we go. I want to start with a little example about building solutions in uncertain environments. I borrowed this storyline from Gene Kim, a new book that he has with Steven Spear called Wiring the Winning Organization. Back in 1962 in the United States, President Kennedy challenged the U.S. to go to the moon. At the time, there was a space race with the Soviet Union. We were behind. In fact, in 1962, we'd only sent a man into orbit for, I think, 90 minutes. That's all we had done. Yet we were being challenged to send a man to the moon, go to the moon and back. It's going to take 12 days to go to the moon and back, and we're going to have to take spacecraft and dock and undock, and people are going to have to figure out how to live and work in the moon. A lot of unknown, a lot of uncertainty, very volatile environment space. Yet just 7 short years later, Neil Armstrong became the first man on the moon, where he gave his famous quote, "One small step for man, one giant leap for mankind." But we want to ask, was it really one giant leap, or was it a series of much smaller leaps? And I won't go through the details. We don't have a lot of time, but there was a lot of unknowns. How are men going to live and operate in space? What spacecraft design? How are they going to re-enter? How are we going to dock and undock to send men down to the moon? Where are we going to land on the moon? We had to actually go to the moon a few times and look for good landing locations. And so all in all, there were 24 missions into space, or averaging one about every 7 or 8 weeks, to go get that type of learning. And then on what was that date again? Excuse me. In 1969, Neil Armstrong became the first man on the moon, where he gave that famous quote, "One small step for man, one giant leap for mankind." But as we see, it really wasn't one giant leap. Back in 1962, we were not smart enough to specify that Apollo 11 aircraft, the lunar module, the docking procedures, the docking mechanisms and procedures, all of the infrastructure required back on Earth to do the communications and procedures. We just weren't that smart enough. No amount of detail and requirements, no amount of additional specification in the design is going to be able to design that spacecraft. We have to go into the operational environment, learn, and give feedback. And really, that's what the essence of Agile is, right? It's the experimentation. It's really what engineering was. We all went to engineering school, but we didn't take the work breakdown structure class or the phase gate milestone class, right? We took the class that taught us how to do things in small batches, learn and make adjustments, right? So really what we have is a roadmap of learning milestones. What don't we know? What do we need to learn? How are we going to survive in space? How are we going to live in space? How are we going to maneuver an aircraft? How are we going to dock and undock? How are we going to go to the orbit? How are we going to get to the moon and back? Circling the Earth multiple times to gain the velocity to go to the moon, and then slowing down at the moon. All those things are assumptions until we actually try them in the operational environment. So we create a backlog of work. What work could we do to go gain this knowledge? And then we build the solution to go gain that knowledge. We don't build one solution at the end. We build solutions incrementally that go gain that knowledge for us. So back in the 1960s, NASA operated this way, surprisingly enough. And I have worked on multiple NASA programs over the last 20 years. And I'll tell you, we don't operate that way anymore, surprisingly. We have this big batch of requirements up front, followed what we call the V model. And I think really we're getting back into this environment. If you think about how SpaceX operates or Tesla operates, or we'll give examples of non-SpaceX and Tesla in this presentation as well. So how did we get here? How do we get to this Lean Agile type of environment? Well, back in the late 1990s, early 2000s, you may remember the .com boom, the digital boom of software and digital. Back then, Carlota Perez was wondering, all this capital that's flowing into all these companies, is that a unique occurrence or has it happened before? And she actually did a study and found out that No, there have been many technological revolutions prior to that one. In fact, just back up the previous one, back around 1910 or so, was the age of oil and mass production. And in Detroit alone at that time, there were 300 automotive companies, not just worldwide, but that was in Detroit alone. And she noticed there were a pattern that each one of these technological revolutions follow. A mass amount of capital flows in, a lot of companies start up, and then there's a turning point where a small number of those companies figure out the new technology. And they're the ones that reap the benefit in what she calls the deployment period, right? Where they prosper, from having figured out that technology and applying it. And we saw, in the age of oil mass production, the big three in Detroit, anyway, they're the ones that figured it out and won, and different set in Europe. And we see that in the age of software and digital, where certainly some companies have won, right? Motorola used to be the largest employer in my state, Arizona, and they are certainly not anymore, right? Motorola owned 90% of the phone market, but they lost it when they moved to digital. They owned analog phones. They lost that superiority just in 2 or 3 short years, right? It only took 2 or 3 years for them to go to 90% of the market to not 90% of the market. And we see other ones, Amazon, Netflix. Most of these are most of these are software companies. We're seeing now the same type of disruption in companies that build cyber physical products in space, automotive, even defense and weapons systems, right? I've done quite a bit of work in defense for the United States. We're seeing the same kind of need as our threats and competitors innovate much faster than it takes us 7 to 10 to 12 years to build some of the systems that we're building. So we're seeing the same kind of disruption going on. Now, going back to Carlotta's book, what was interesting was she noticed that in every technological revolution, we didn't just introduce a new technology, oil and mass production, age of steel and heavy engineering, right? We invented steel and manufacturing plants. Well, in that era, we gained Taylorism, which was we're going to optimize the individual steps. We're going to take a practitioner that's operating this manufacturing line. We're going to optimize that individual, right? An expert or somebody that's been doing it for 10 years will go coach or teach. We'll be a lead for that group, and we'll optimize the steps for them. The age of oil and mass production, we get Fordism, where we automated those steps, right? A bunch of automation for standardization, automation, those types of things. In the age of software and digital, we're seeing a new way of managing working people that's more around Lean-Agile, different type of leadership models, right? Servant leadership, right? We have knowledge workers who operate differently than the traditional, where knowledge workers operate and behave differently than other type of workers. And we're seeing that kind of change. And we think Lean-Agile continuous learning model is the one that fits there. Now, in this age of digital disruption, we see some common characteristics by those organizations. One that's really focused on learning, right? Peter Senge here, love his quote that, really our only competitive advantage is, can we learn faster than the competition? How can we learn faster, be more innovative than our competition? To do so, there's certain characteristics around process and technical development. We don't build one system one time 7 years down the road. Instead, we focus on faster delivery, minimum viable products, right? The NASA approach. That first rocket we launched wasn't the one that was going to go to the moon. It was one that was going to gain the knowledge for us to build the next rocket, which would build the next rocket, right? We build something, get feedback, and make adjustments. If we're going to be building this thing more frequently, we're going to be really optimizing the design for change. Instead of being optimized for unit cost or unit manufacturing cost, that is certainly certainly a factor. But also, how easy is it to make changes here in the operational environment, in the engineering environment, so that we can learn faster? We have what we're going to talk about later, value streams that don't just blend engineering functions, but also all the way out that operational environment. If we're going to launch every 7 to 8 weeks, then I need everybody on the value stream, the people that are responsible for launching, the people that are responsible for the operational procedures. Everybody's on that value stream defining the next rocket for the next mission. And then cross-functional teams around, right, engineering operations. So it's not just process and technical, it's also cultural, right? We're very customer facing. We understand our customer. In fact, we instrument our systems so that we can gather the data in that operational environment about our customer's behavior, right? A lot of data gets gathered by all these environments, and we bring that back into a big data environment. We have teaming and working without boundaries. We try to reduce functional silos, which we'll talk about later. We're focused on not just those vertical functional skills. I don't just need skills for the department that I got hired in. I need skills to go build the product, the solution that we're building. And it's okay for me to do cross-functional skills. And maybe I'm a mechanical engineer, but I might be writing some code here and there, some algorithms, or I might be doing some electrical design, because that's the most valuable thing I can do today. Right? And we see that as we move engineers into cross-functional teams and cross-functional value streams, that they do pick up these cross-functional, what we call T skills. And the last one's big, we'll talk about a little bit later, is the permission to fail. It's okay, if we're going to do experimentation, we've got to make it okay for those experiments to not always be successful. And we'll talk a little about that later. All right, with that said, we're talking about a series of practices based on Lean-Agile principles that help us accelerate delivery for these types of systems. And I'm going to go through 4 of those 9 up there. The first one is probably the most important. It's the why. We're going to focus on shifting left. How can we focus on creating a shift left mindset? So the systems we build today have a lot of uncertainty, unknowns, just like we were back in 1960s with NASA. There's technical assumptions we have. There's market assumptions. There's user assumptions, right? If we have these very long engineering development cycles where we don't get feedback on these assumptions for potentially years, right, that delays feedbacks and creates really its own set of risks. So instead of in that waterfall approach where we get one time to build the system, one time to put that system into operation, one time to learn, we want to do that as frequently as we can, right? These series of these plan, do, check, adjust cycles. We want to iterate those things more frequently so we get more opportunities to learn. And that's really the essence, really a lean, right? This is really a lean principle, right? That the Agile folks have adopted. Ironically, most of the Agile practices are really based on fundamental lean principles. So this should be a natural connection for automotive because, lean really grew up in automotive, Toyota production system and those practices. And that's what the goal here is. We want to do short, faster learning cycles. How fast can we decide what to build it, put it in some kind of environment for feedback and make adjustments. And the faster we iterate, right, the faster we're going to learn. To build this environment, what we've done in the past in the digital age is we built the infrastructure to do this more quickly. So we have what we call in the Scaled Agile framework, a thing called the continuous delivery pipeline. That is the automation of the workflows, activities, to be able to develop, test, and release smaller increments of value. If we're going to deliver faster, then we need to invest in the automation to be able to deliver faster. Okay, and that requires an investment by organizations. And we see huge examples of these investments. I ask people frequently, how many people have heard of Amazon Web Services before, right? Most people have heard of AWS. I can't see you, but I assume people are raising their hands. Amazon has a product called AWS, but it was not designed it was never intentionally designed to be a product. Amazon built the AWS technology so that back 20 years ago, probably 25 years ago, there was the first investment. 25 years ago, they were investing in the infrastructure for Amazon to be able to deliver its software products more quickly. It's music products, it's retail products, it's infrastructure products, right? They built AWS as an internal product. They were just so good at cloud infrastructure that they made it a product and sold it commercially. There's many other examples in the software community investing in infrastructure. Google has Kubernetes, if you've heard of Kubernetes, right? They built the infrastructure for microkernels and microservices. Anyway, so there's a great book out called Accelerate, many examples of this infrastructure to accelerate faster. And the question becomes, is faster delivery, these DevOps faster delivery principles and practices, do they equate to business results, business performance? And this book, Accelerate, did a 3-year study and found out that, yes, it's true. The highest performing companies, those highest performing companies, deploy more frequently to an operational environment, 46 times more frequently. The lead time for an engineering change into an environment for feedback to a deployed environment for feedback is 440 times faster. So where some people are getting feedback, on a monthly basis, possibly weekly or monthly basis, These companies are getting feedback on an hourly basis, right? How frequently can I deploy something in operational environment? Engineers get feedback and can make adjustments. But it's not just how fast it's not just how fast we can go, right? Those first two bullets are how fast we can go. We also go fast with quality. Some people make the assumption that if I go fast, then I'm going to lose quality. And the opposite is frankly true. The faster we go, because we built in all that automation infrastructure, we go faster with higher quality. So those companies also have smaller change failure rates, and they also have, and then when they do change, they can recover much more quickly. So with the infrastructure they've built, they can go faster. They go faster with higher quality. When they do have problems, they can recover 5 times faster. Right? Great book, great examples. Now that's primarily in the software industry. As we said, the software industry is probably 20 years ahead of us. Right? This whole agile practices started about 20 or 25 years ago. So the hardware community has just begun its journey. Different technologies are going to follow different continuous delivery pipelines. And we even see that in software. There's different software pipelines for packaged application than there is for microservices and there is for embedded systems, embedded software. But we have a pipeline nonetheless, right, for every one of those. What would hardware's pipeline look like? Well, hardware's pipeline looks like really multiple environments. Learning occurs in 3 environments on hardware. Certainly we can learn in the operational environment. We get our physical product into an operational environment like we saw in NASA, right? At every 7 to 8 weeks, NASA was launching another rocket. Sounds like SpaceX, right? SpaceX does the same thing. But we also can learn in other environments. Certainly there's been a large investment in a virtual environment, digital twins, digital shadows, modeling and simulation environments. We've been doing modeling simulation in hardware for quite some time, but this is really the integration of multiple CAD models and multiple simulation models and environments so that we can be not just modeling and simulating a piece part, but also certain aspects of the entire system, right? So big investment in virtualization. We can also learn faster in a prototype environment. We can 3D print things and PCB in a day. So even if we don't have the technology or the competency in-house, there's services that other organizations provide. You can send them your CAD models and they can turn around and produce parts, produce your printed circuit boards like in a day or a week or so. We don't need to have the technology in-house. Although it's nice to have the technology in-house, but it's not required. So big successes, we've seen big successes in every one of these examples. Let's pick on that virtual environment first. I love being able to talk about organizations that are not Tesla and SpaceX, right? Let's talk about 100-year-old companies that are seeing benefits from some of these examples. So General Motors recently released the Hummer EV. If we back up 4 years ago when they were first challenged to produce the Hummer EV, we knew electric cars were in the forefront. General Motors makes a lot of money off the trucks they build. And so the CEO challenged the Hummer EV team to produce a product in 3 years. And in fact, they were able to produce that product in 2 years, despite the fact they've never produced a new vehicle line in less than 6, right? So initially there was pushback and saying, well, we can't produce. We've never done anything shorter than 6. How are we going to do it in 3? Well, there was a research group within General Motors looking at digital engineering tools and digital engineering infrastructure. So the Hummer EV team became basically that engineering group's first customer and said, you're going to get over here and you're going to help us build the Hummer EV in much shorter time. And suddenly they were able to do that, right? They went in it was slightly over 2 years. They went from the proposal to have a Hummer EV to actually manufacturing the trucks and sending them to dealerships. And they credit the fact that they already had that digital engineering infrastructure so they could learn faster with hardware in the loop testing and modeling and virtualization, simulation environments. So they were able to skip several of their traditional vehicle milestones. In fact, they made the first prototype car a year before they actually started manufacturing, selling them. That was the first physical prototype car, right? So they would skip a lot of those physical milestones because of virtual. There's many other examples. I like to call out GM because it's not one of the unicorns. But as far as prototyping and manufacturing go, we're integrating not just the digital environment, but the prototype and manufacturing environment. SpaceX is a great example. SpaceX launches just like NASA did back in the day. Rockets every can be weeks, right? Weeks or months. It's the next launch, and each one of those rockets can be slightly different than the next. Might have a new nozzle, different nozzle shape. Might have a different fuel tank, fuel assembly. How do they do that? Well, SpaceX, again, for the continuous delivery pipeline and hardware, they've invested in the largest metal 3D printer in the world, and they have it on site down in Texas. If we're going to be launching rockets, we need to be able to manufacture the rocket parts. So we invested in the largest metal 3D printer in the world, and they 3D print a lot of that rocket. They also have to skip steps in the manufacturing process. They attach an X-ray machine to the welder, so that as they're welding, they're validating the welds in real time. They get real-time validation of welds. So there's not a welding activity and then a separate validation activity, right? They do real-time. They build quality in basically into that pipeline by validating real time. So great examples there of investing in hardware continuous delivery pipeline. So again, we're seeing the emergence of this. People integrating that end-to-end value stream with automation, right? Digital modeling and simulation, as well as prototyping in the manufacturing environment. But they haven't been standardized yet like they have in software, but those victors will emerge, as we saw from the Accelerate book, right? The organizations that figure out how to deliver faster and leverage this technology will be the ones that reap the benefits for decades to come. And just like we've seen in software, I think we'll see that same thing in hardware. So next thing I want to talk about is organize around value and value streams. Value does not follow silos, as we say. We need a lot of different functional expertise to build the systems we build, right? There's engineering disciplines, science disciplines, and they all have to contribute their knowledge and value to produce the solution we have. The challenge is in most organizations, we try to optimize our functions. We don't optimize the flow of value across those functions. So if you look at any value stream, certainly there's work to be done, right? The hour worth of work here, 5 days worth of work there, a day worth of work here. The delays come in the fact that we hand that work off between people. I'm an engineer. I'm working on 3 or 4 different programs. Someone hands me work on this program. In the meantime, I'm delaying the work for many other programs, and those delays add up, right? And usually if you do any kind of what we call value stream mapping, another practice we got from Lean, we'll find that a majority of our time is actually spent waiting instead of doing the work to produce value. So to minimize these delays, we don't organize around functions. We organize people around value streams, right? And we put value stream leaders responsible for those value streams. And we give them the budget and authority and decision-making process to be able to optimize those value streams, right? So instead of the power and function being in the functional areas, I've worked in organizations that have varying amounts of this. I've worked in organizations where the functional areas are very strong. They bring their practices, they bring their budgets. People are not allowed to work outside of that work and practice, right? As I talked about before, that I'm a mechanical engineer, but I'm doing a little work in other functional areas. Might be helping out write some code, might be helping out running some regressions on some kind of a PCB design or something, right? Whatever those valuable work is today, I will do that work. If you have strong functional areas, they say you're not going to use my budget to do that work. You're going to use somebody else's budget to do that work. So we take those conversations away. We give the budget, authority, decision-making to the value stream, and then people dotted line work on those value streams. We have a great example of this from one of our SAFE summits by Bosch. They talked about how they used to be organized around departments back in 2015, system engineering, software, hardware, mechanical, different functional areas. Then those individuals will go work on programs that produce certain products, for this is their steering mechanism group. And then they embarked on this journey, this 5-year journey back in 2016 to organize around value. So they talk about how they created 11 agile release trains based around the modular components of the steering mechanisms, so that now 90% of the engineers, my little cursor, here we go. 90% of the engineers are actually here building the product line of components. And then 10 or 15% of the engineers are here that are integrating those components for the different products that they sell to different customers, right? So instead of being organized on functional areas, we're organized around the valuable components, product line of components that then get integrated into the solutions people build up here. This is not new in automotive. Most OEMs I work with are optimized and organized this way, around building the components and capabilities and then integrating them into the vehicle products. But it really depends on the OEM. I've done quite a bit of work with General Motors, for example. these would be the vehicle lines up here, right? And these would be infotainment, powertrain, chassis, etc. Other organizations aren't, right? But you look at some organizations where they're not. The powertrain that I build doesn't go into every car. Powertrains are done by specific types of cars. All right, let's push on. I got to finish this. The next challenge we have is integrating the end-to-end solution. We want to frequently integrate that end-to-end solution. Why? Because if we're doing PDCA cycles, we need the ability to integrate these solutions end-to-end more frequently. And in fact, that continuous pipeline is part of the infrastructure to help automate this, so we can integrate that end-to-end solution more frequently. But in hardware, learnings are often done in a local context, where we have a camera here, a camera team, and to build the camera, we have some kind of light sensor that we're maybe getting from a supplier. And then we've got a FPGA, we're going to do analog digital conversion. And then these chips plus a bunch of peripherals have to be built inside of some kind of printed circuit board that eventually goes into a housing. And that housing eventually gets mounted on a chassis with an interface out here to some vehicle control. We're going to send out a signal, our digital signal to vehicle control. Well, typically, if we're organized around functions, these people are just, they have a specification that's come in. And then we just do our work. And then eventually we're going to integrate the system at the end here where we get the final product. And we find that doesn't work. I mean, the PCB board may need to expand to have some peripherals, and then that's going to affect the design of the housing or the housing here. And then really, as we start integrating that on the vehicle body, we might learn about the shape and design of that might affect the PCB design. And the FPGA may need to get bigger or have more power, right? There's all kind of unknowns and uncertainty. And that's really why we create these cross-functional teams. We put all these skills on a single team, and then they are integrating more frequently, right? They're collaborating on a daily basis. And then every few weeks or so, they're integrating their solution. Might be a physical integration, might be virtual integration, modeling and simulation, as we mentioned. But really, that's the point, is those integration points control product development, right? A great book, Don Osterwald, called Lean Machine. He was an executive at Harley-Davidson, another book we like to recommend about frequent integration, fast delivery, fast learning, right, in hardware. And that book was written 20 years ago, right? More than 20 years ago, actually. So we've been, this idea of integrating faster has been around for quite some time, even in the hardware space. But it's not sufficient that we integrate the camera product, this team, right? We want to integrate the end-to-end system. So we need that frequent integration, modeling of virtual digital environments, prototype environments. We need to invest in that infrastructure so that there's a way for, again, lead time to change. We saw in the Accelerate book, the people that integrate faster are the ones that win in this new digital age, right? How can we integrate faster to get faster feedback? All right. This fast integration has business benefits. It goes. So just this year, Tesla had a recall of 2.2 million vehicles. Usually recalls scare manufacturers, but now for Tesla, that's just another over-the-air update. It's in our DNA to deliver faster, deliver more frequently. So if we have a recall, that's just another over-the-air update, right? And it's not a big deal. Again, just a few months ago, another recall over our seatbelt warnings. Well, again, that's just another over-the-air update, right? Announced the same day. The same day they announced the recall, they announced that, by the way, we've got a fix for this, right? That's true business agility. When something makes the press, like a recall, when we can address that recall, with an over-the-air update, that's that value to the business. Now, frequent integration can have its challenges. We're going to integrate more frequently. We're going to, not all these integrations, if we're going to be building the system more frequently, some of these systems will not operate and be successful. I love this example from SpaceX, though. I guess it was last year about this time. SpaceX does these really big launches. When they blow up dramatically, they all make the news in the press. But how does SpaceX respond just a few hours after that launch? Right? With tests like this, success comes from what we learn. We know it's all about learning, trying to learn fast in the competition. And sometimes this is what learning looks like. Learning looks like blowing up a rocket. In fact, they have a term for it. We all have our acronyms for things. They have what they call a RUD, an RUD, a rapid unscheduled disassembly. When a rocket blows up, we just call it a RUD. We don't call it a failure. We call it's a rapid unscheduled disassembly. So very cool that their organization recognizes that and build that into their normal process. All right, I'll end with this, and we'll have some questions. Who owns the system? Do the engineers and practitioners own the system they operate in? Can they organize around value? Can they invest in the infrastructure to go faster? Can they invest in the designs that make them go faster? They have to focus on designs that are focused on unit costs. And the answer is no. Leaders lead that. And that's really, Edward Demings is one of our, founding leaders. And that's what he talks about here, is that really management has to commit themselves to understanding this new way of working and then leading the change, right? Because we really just are talking about a new way of operating, a new way of managing work and managing people. And that system's owned by management, the leaders. And going back to that Bosch presentation, in the beginning, Simon talked about how he connected with the top executive of engineering at Bosch and worked with that engineer on understanding. There's Dontar's book, Lean Machine. And he said this leader was just a sponge. They just consumed more information, more knowledge. He read the book Lean Machine in a week and said, what's the next book? So he gave him Turn the Ship Around. What's the next book? Start with Why. And that's really the kind of passion we want from leaders. They need to understand not just that we need to change, but what the change looks like so that they can help lead it. Thank you. And with that, I'll take questions.
Thank you so much, Harry.